Okay, so this is number 10 on the review. So it says tangent of 75 degrees. So we want to be able to, it says in the directions, use addition and subtraction identities to find the exact values. So what values can we use to rewrite tangent of 75 degrees? These are angles that we want to know that we can find the exact values for.
45 and 30.
So we can use 45 and 30. So tangent of 45 degrees plus 30 degrees is going to equal that 75. So now we're going to use the identity for tangent addition. So that says tangent of 45 degrees plus tangent of 30 degrees divided by 1 minus tangent of 45 degrees times tangent of 30 degrees. So now if you don't remember what those are, draw your triangles. So there is our 45, 45, 90 triangle and our 30, 60, 90 triangle. So what is tangent of 45 degrees?
1.
1. Tangent of 30 degrees
Root 3.
is just root 3?
No, root 3 over 2.
It's
I
root,
mean 1.
Root
Yeah.
3 over 3.
it's root 3 over 3 once we rationalize. And then we have our 1 on the bottom minus that 1 times the root 3 over 3. So then we're going to simplify the bottom. So we end up with 1 plus root 3 over 3 all over 1 minus root 3 over 3. So now can we leave our answer like that?
No.
Why not?
Can't have the radical.
We can't have the radical in the bottom. So to make this easier, before we multiply by our conjugate like we did yesterday, before we do that, we should times the tops and the top and the bottom by 3. That way we can get rid of this fraction, and then we just have more whole number kind of answers. So we're going to multiply the top and the bottom by 3. So I'm going to move over here. We're going to end up with 3 plus root 3 over 3 minus root 3 once we multiply by 3. That's just to get rid of that fraction. It makes it a little bit easier. So now we still need to get rid of that radical. So as I said, we're going to multiply by our conjugate, which is 3 plus root 3. So we're going to have to FOIL the top and the bottom. On the top, we're going to end up with 9 plus 6 root 3. And then root 3 times root 3 just gives us a 3. And then on the bottom, we have 9. And then because this is the difference of perfect squares, we have just the, our first times our last. So again, we have minus root 3 times root 3, which is just 3. So then when we simplify this, we're going to get 12 plus 6 root 3 all over 6. And then is that our answer? Why not?
Because you can rationalize.
Because we can still factor out that 6, right? So this is going to equal 2 plus root 3. And 2 plus root 3 is going to be your final answer once you factor out that 6. So make sure you are simplifying these as much as possible. All right, now we're going to move on to number 11. And number 11 says cosine x equals negative 4 over 5 equals negative 4 over 5. And we're told that that x is between pi over 2 and pi. And then we're told to evaluate cosine of pi over 4 plus x. So these are like the problems that we looked at yesterday. We're given a cosine value or some sort of ratio, and then we're told where that angle lies. So if our angle is between pi over 2 and pi, what quadrant are we in?
The second.
That tells us that we're in the second quadrant. So if we were to draw our angle, we have some angle over here in the second quadrant. That's our x. Now we're told that the cosine of that angle is negative 4 over 5. So what can we do with that negative 4 over 5? So we can label our triangle. So the negative 4 is my adjacent side, and then the 5 is my hypotenuse, because cosine is adjacent over hypotenuse. So then I need to find my third side, which we'll call y for right now. So how do I find that third side? So I'm going to use the Pythagorean theorem. So I'm going to have y squared plus negative 4 squared equals 5 squared. I end up with y squared equals 25 minus 16, so that gives me 9. So y equals 3. So now I want to use that triangle with this problem when I expand it out. So I have to expand this out using the cosine addition identity. And that said cosine of our first angle times cosine of our second angle subtracted from sine of our first angle, sine of our second angle. So we already know how to find cosine of pi over 4 and sine of pi over 4, but we needed that triangle to find the cosine of x and the sine of x. So what's the cosine of pi over 4?
One over square root
1 over square root 2, or if we rationalize,
2.
root 2 over 2. Then we're multiplying by the cosine of our x, so the cosine of our angle that we found over here. So that's negative 4 over 5. Then we're subtracting the sine of a pi over 4,
2 over 2.
which is root 2 over 2, times the sine of our angle.
3 over 5.
Which is 3 over 5. So then when we multiply across, we're going to have negative 4 root 2 over 10 minus 3 root 2 over 10. So now these, we have common denominators, and if you notice on the top, we also have the same roots, so we can actually combine this entire thing. And that's going to give us negative 7 root 2 over 10. And then finally, number 12. Number 12 is very similar to number 11, except this time we're given two different angles instead of just being given one. So this time we're told that sine of x equals 4 over 5 where that x value is between 0 and pi over 2. And then we're given cosecant of another angle y, and that equals 13 over 5. And that y value is between pi over 2 and pi. And we're asked to find sine of x plus y. So for our angle x, we're told that it's between 0 and pi over 2. So where are we with that angle then?
First quadrant.
That's the first quadrant. And then with our cosecant, we're told that that's between pi over 2 and pi.
Second.
So that's the second. So now, just like we did in 11, we want to make triangles for this angle and this angle. So for our x, we're in the first quadrant, so we have some angle in the first quadrant. And we're told that the sine of that angle is 4 over 5. So we can label our triangle. We have our opposite side is that 4. Our hypotenuse is the 5. So then, again, we want to find that third side. So we're going to take and use the Pythagorean theorem again. We'll call this z this time just so we don't confuse it with our angle x. So we're going to have z squared plus 4 squared equals 5 squared. We get that z squared equals 9 again because 25 minus 16. So we get that z equals 3. And then we want to do the same thing for our cosecant. This time we know that our angle is in the second quadrant. So this is our y angle. Now for cosecant, how do we label our triangle using cosecant is 13 over 5? What do those values represent?
The opposite of sine.
So it's the opposite of sine because cosecant is 1 over sine. So what was our definition for sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So if cosecant is the opposite of that, what is?
Hypotenuse over opposite.
So this is our hypotenuse over our opposite. So when we label our triangle, our hypotenuse is 13, our opposite side is that 5. So again, we want to find that third side. We'll call it z again. So this time we have z squared plus 5 squared equals 13 squared. So we end up with z squared equals 144. We have 169 minus 25. So we end up with z equals 12. Now, remember we're in the second quadrant. So our x value is negative. So this is actually negative 12. So make sure you put that negative in. That's why they tell you which quadrant you're in. So now we're going to use both of those triangles to find sine of x plus y. So that's our sine addition. So we have sine x times cosine y plus sine y cosine x. That's just expanding using the identity. So now we actually need to find each of these values. So sine of our angle x. What's sine of our angle x?
4 over 5.
It's 4 over 5. And then we're multiplying by cosine of y. is negative 12 over 13. And then we're adding the sine of y,
3/5. Wait. Oh, shoot.
the sine of y
5/15.
is 5 over 13. And then we're multiplying by the cosine of x. It's 3 over 5. So then, just like before, we're going to multiply across, so we're going to have negative 48 over 65 plus 15 over 65. So then we can just combine those. We end up with negative 33 over 65. So that's our exact value for the sine of x plus y.